Today we are going to be talking, we're going to go into 1-2 today. 1-2 is one step farther than what we did yesterday. It's just one step. And it's not even that big of a step. So 1-1, we talked about getting rid of the parentheses, combining like terms, right? 1-2, we're going to see something like this. So, take out your journal so you can get one of these problems inside of your journal, please. One or two of these problems. So let's say we had 2x negative 4x squared plus 2x minus 7. And we'll leave it right there for now, and then we'll combine them in a sec. So this is called, we're going to call this multiplying, and botched that, multiplying a monomial to a polynomial. So we're going to multiply a monomial to a polynomial today. And then we're going to go into, and then we're going to use what we did last time and combine like terms at the very end. So, if we have this problem, 2x times negative 4x squared plus 2x minus 7. The way we're going to multiply this is just by distributing that 2x to everything that is inside of it. So who can tell me, I want to get an idea here, what is 2x times negative 4x squared? Raise your hand if you think you're 100% confident what that is. Close. What did you, close, I think I heard that. Yeah, Preston?
Negative 8x.
Nope. So let's think about it. We got to go back to our Math 1 days. When we multiply exponents, we add them. So this exponent right here has a 1, right? Even though it doesn't tell us it has a 1. So x times x squared is x cubed. So we have 2x times 2x, which gives us 2 times 2 is 4. X times x is x squared. And then 2x times a negative 7 is just negative 14x. Okay? So when we multiply exponents, we add them. Let's look at another one. If we had negative 6d cubed, 3d to the 4th minus 2d cubed minus d plus 9. The way I would do this is I would distribute this from the outside to everything on the inside. But the biggest thing you got to remember is we multiply the whole numbers. Negative 6 times 3, which is negative 18. D cubed times d to the 4th gives me d to the 7th. When you multiply exponents, you add them. Negative 6d cubed times negative 2d squared, d cubed, gives us positive 12d to the 6th. And it gets kind of confusing because you're going to want to multiply the exponents too, but it's not that. You multiply the whole numbers, you add the exponents. Then we have negative 6d cubed times negative d, which is positive 6d to the 4th. And negative 6d cubed times 9, which is negative 54d cubed. Because this already has a d cubed, right? So it just comes on with it. Any questions so far? You might not even know what questions to ask right now. That's all right. Question. Preston, if you talk again today, I'm going to make you have 50. Deal? Okay, here we go. Let's put stuff together now. So this is the stuff that the lesson's going to be about. That was just an introduction. This is going to be what we're dealing with. Okay, if we look at this problem, believe it or not, it actually looks kind of similar to even our quiz, right? We have two polynomials. Basically, we want to get rid of the parentheses. We want to combine like terms. But in this case right here, we have an issue. There's a monomial in front of each polynomial. So the first thing we have to do is we're going to actually distribute the monomial to everything in front of it. So, for example, this 2p is going to get distributed to here, and this negative 5 is going to get distributed to there. Okay, so right now what we're working on simplifying these expressions. So 2p times negative 4p squared is negative 8p cubed. Does everyone understand how I'm getting negative 8p cubed? I multiply the whole numbers, I add the exponents. Then we have 2p times 5p, which is 10p squared. And notice I'm getting rid of parentheses as I go, the first step. Then we go to the next one. Negative 5 times 2p squared is negative 10p squared. And negative 5 times positive 20 is a negative 100. Something's happened though. Yeah, so remember yesterday, first step is to get rid of parentheses. We did it. Next step was to combine like terms. So we look at this. Do we have any like terms there? Do we have another p cubed? Nope. So we know that's going to come part of our answer. But look at these two. Are they like terms? And they just cancel each other, right? Because 10p squared minus 10p squared just cancels. And we're left with 100 right there, and there's your solution. All right, let's look at another. Let's say we had 3 times 5x squared plus 2x minus 4. Positive or negative, Travis? Positive x, 7x squared plus 2x minus 3, Lane. Sound good to you? Okay, write that one down. All right, let's go through this real quick. A lot of you guys are already working on it, which is good. So we're going to distribute this 3 all the way through everything, right? So it's going to give us 15x squared. You multiply the whole numbers. Plus 6x minus 12 plus. Okay, I'm going to start asking for your guys' help. You guys ready? So get your mind right. I'm going to call on people. What is x times 7x squared? I'm going to call on people. Kaysen. 7x cubed. Right? Okay. What is x times 2x squared? Sid? What is x times 2x? Sorry, x times 2x. Perfect. And Brianna, what's x times negative 3? Perfect. Okay, so we're to here. Kenston, what do you think we do next? Okay, Kenston, what term would you start with first? Okay, do we have any other x cubes? So we're just going to bring it down, right? Okay, Liv, what do we do next? So we have 15x squared and 2x squared, which gives us 17x squared. And then we have x, so 6x minus 3x is positive 3x. And then just negative 12 on the end. Questions? Brandon, what do you think? You guys ready to try one on your own? Here, try one on your own. Cerise, scale between 1 and 10. How hard do you want this? Between 1 being really easy or 10 being really hard? A 1? That a girl. 6 is a good choice. All right, let me find. Actually, we're going to come up with our own 6. You guys ready? All right, where did we end? I ended. Lisa, tell me your favorite number. Let's go 7x squared. Okay, London, tell me your favorite number. 7x cubed. Preston?
7.
Minus 3x. Cerise, tell me a number. Plus 4 minus, Derek?
7.
I didn't mean to put that. Ignore that line. So 5x 2x squared plus 6x to the 4th minus, Dan? 17 x to the 3rd. There you go. That's about a 6. I could have gone to a 10. We're going to go to a 10 next, so. Things are going to get real. People going to be fighting. You guys like how when Dan said 7, I said 17. Got him. Jerk. Dan? Dan's shaking his head. Not today. Trey. Woo. Trey. Woo. Wakey, wakey. Late night gaming?
No.
Playing a little Fortnite?
No. Yes, we both Fortnite. I love Fortnite. Preston really loves Fortnite. I'm sure I get the right person.
I like watching when people get to the point where you start combining like terms. Everyone has the exact same reaction. You always write, and then you lift up your finger. And everyone goes like this. They can see the whole problem. Then they write, and they lift up their finger. And they write, lift up the finger. I do it too. That's how I know. Do we have any like terms when we do it? Yeah. Boom. Hey, I'm going to take away a phone today, I can tell that. You're just judging by how many phones aren't up there. Today's the day I take away phones. I just got a good feeling. Liv's going to put it up right now. 28 minus what? Negative 2. Trent, what are you doing? All right, so we ended. Trey, where are you?
Why?
Actually, we're at Maddie. Maddie, tell me what you do first. Get ready, Trey.
7x squared, so all those things.
Okay, so do it for me.
So 49x to the 5th minus 21 to the third
X cubed.
plus 28 squared x squared.
Does everyone agree with Maddie on the first part there? Right? Breathe through your nose. Brandon, did you get the first part right? Okay, look at the first part. Multiply them, add together the exponents. Okay, Trey. Next part.
You gotta distribute 5.
Negative 5x.
That's negative 10 cubed.
Okay.
That's negative 35 to the 5th.
30.
Same thing.
No.
Yeah.
85.
85 to the 4th.
Does everyone agree with Trey? Okay, Juliana. Do we have like terms? Okay, which one did you start with? Yep. So we have 49x to the 5th and negative 30x to the 5th. So it gives us 19x to the 5th. That'll be our first term, right? Yes.
On the end of that problem, the exponent with the 85x, so it says that's a 3 exponent on 17.
Yep.
And you add 2. So that's
There's only a 1 right here.
oh, I was just not talking about that.
Yep. Good question, though. Okay, Trent, what's the next one we'll do?
85.
So 85x to the 4th.
Yeah.
Is there any other x to the 4th? Nope. Okay, Miranda, which one would you do next? Someone help her. Kinley, do you know which exponent would do next?
We'll do the 21x and then,
Yes?
the 21x and then 10x.
Good. So we combine those, we get negative 31x cubed, right? Because they're both negative, so you combine them. Lane, what do we do with this? Just tack it on the end. That's a welding term. Okay. All right. And there's your solution, right? Who got it right? Raise your hand. That's not too bad, actually. I actually was kind of thinking that'd be a little worse. Hey, so the biggest thing you guys got to remember is this, and I've noticed this a lot when it comes to when we start doing this, that we have to make sure we add the right exponents. So we got to remember to add the exponents. I see a lot of people when they start going here, when they go 7x squared times 7x cubed, they put 49x to the 6th. That's wrong, right? Something that small can change the entire problem. We have to add the exponents. All right? So, let's look at it a little bit harder. If we see something like this, and I'm going to start off pretty easy on this. So, 2x 10x squared y cubed minus 5x y squared. We'll go x cubed y squared. And then on this side we'll go minus 10y y x squared y plus 4y squared. That's a squared right here. X squared y. Alright, this problem right here is going to be a little bit harder, but it's honestly not too much harder, so don't panic over it just because it looks like it's a nightmare. Right? Nothing changes. So what we're going to do is we're going to distribute this 2x through. We have 2x times 10x squared y cubed. We're going to multiply the whole numbers to get 20. We have an x. The x gets multiplied with the x. So x times x squared is what? X cubed, and there's no y, so the y just comes down. Everyone see that? There's no y, you're not multiplying a y, so the y just comes down a part of it. 2x times negative 5x cubed y squared. 2 times the negative 5 is negative 10. X times x cubed is x to the 4th. and the y just becomes part of it. So far, so good? So let's look at the other one. Negative 10 times 1 is just negative 10. The x squared just comes down. Y times y is y squared. Negative 10 times 4 is negative 40. Look, is there an x on this one? No, there's no x on this. There's no x on that. So just y times y squared is y cubed. Now we combine like terms. Do we have any like terms? Oh, well, but wait, they all have an x and a y. None of them are exact. They have to have the exact variables and the exact exponents in order to combine the like terms. None of those are exact. They're all different. Maddie, question?
I was just wondering how, like, we need to put the 10 to the x, not, because, like, isn't it 10y, not just...
Okay, x always goes first. When we multiply this to this, we're still that's still x squared is just coming part of it. So x always goes first because alphabetical order.
Isn't it 10y? Like, you can't
It is.
times
But look, so negative 10y times x squared y. When you multiply those two together, you get negative 10x squared y squared. The x still becomes part of it. Even though this doesn't have an x, the x still has to have part of the answer. Okay, any questions so far?
So we don't have to like, so how it's 20x
Cube.
y cubed minus the 10.
So you're wondering if we had to combine those?
Yeah. do we
Never.
have to?
No, because they're not like terms. It's impossible to combine those because they're different terms. This is like, I had a professor one time tell me this. They have to have the exact same variables, so this is the checkpoints. Do they have the same variables? Yes, they both have an x and a y. Do they have the same exponent? No, they don't, so they're not like terms, we can't combine them. Those are the two checkpoints. All right, let's do another one like this where you have to, okay, Cerise, scale between 1 and 10. Better make it bad. Oh, mother, what is wrong with, okay, here we go. That was probably like a 6 or a 7. So let's go, 2, J. J makes it a 10. I hate J's. 7, J squared. I'll move it up. K squared plus JK squared plus 5K. Is anyone else throwing off that I'm doing a different variable? I think there is, people. I hate J's and K's. That's why I'm doing it. That's what makes this a 10 for me. 2J squared K squared plus 2K squared plus 3J. That's a fun problem. Go ahead, start on that one. Nope. Because you asked. Go ahead and start on that one. Brandon, are you trying? Brandon, are you trying? Yeah, I want you to try. You want to help me out with it when we do it together?
No.
I believe in you, grasshopper. Brandon, are you sure you don't want to help me?
Yeah.
We walk through it step by step. When I don't know what to do, you help me. If you don't know what to do, I help you. No freaking way. Take another 20 seconds. Brandon, we can do it. You ready? Brandon, we can do it together. Brandon. All right, here we go. Brandon. 2 times 7 is what, Brandon? 14. So we have a j times j squared, which is what? Good. J, did you say j to the c? Or was that him that said c? So j cubed, but look at this, so we have an issue. There's not a k out here, but there's a k here, so k squared just becomes a part of that first term. Okay, first term done. We're on to the second one. 2 times 1 is what, Brandon? 2. J times j? So 1 plus 1, what is it? 2, good. And then once again, k squared just becomes part of it. 2 times 5, Brandon? So there's only a j here, there's not a j here, so j just becomes part of it. There's not a k here, but there's a k there, so k just becomes a part of it. See that? So we've got 2j times 5k, which gives us 10jk. Minus, Trav, we're on to you. Negative 9, oh, we got plus right here. Negative 9k times negative 2j squared k squared. What did you get?
Plus 18, j to the second k to the third.
Good. Next one?
Minus 18k to the third.
Bingo. Next one?
Minus 27jk.
Awesome. And I noticed something right there. Did everyone catch what he did right there on that last term? He put the j first. Why? It's alphabetical order. Good. Even though you're times it by k here, a lot of you guys, I know a lot of you probably put k first. Remember, when you're multiplying separate variables, alphabetical order. Because it's important when you look at all these like this, that it's in alphabetical order. Okay, we're combining like terms. Do we have a j cubed k squared anywhere? Nope. Do we have a j squared k squared? Do we have a jk? Yeah, you gotta be. So we don't have one of them. We don't have one of them. Do we have a jk? Right here, right? So 10jk and negative 27jk, which is negative 17jk. Do we have a j squared k cubed? Nope. And do we have a k cubed anywhere? Nope. That is the nastiest answer known to man, but that's your answer. Okay, so great question. Then I was hoping we'd get to this. How do we know, does this have a standard form? No, it doesn't. Okay, it's kind of a weird deal. Now look, every teacher you're going to go throughout when you guys get into college math, things like that, when you're doing polynomials, teachers will have certain ways they like to see it. I don't care about this right here. This just looks like a nightmare, right? So I don't care. I mean, I would definitely, like if it was me, this would definitely go on the end. Do you want to know why? Why do you guys think I would put that on the end? It's a single variable, but there's another reason. All the rest of them have J, and J comes before K. So I always think of it like this. If you have J and you have K, there's a lot of area in between them, right? So as long as it has a J, it's somewhere up here. But as soon as it has a K, then it's right here. So if it was just a J, if there was just a J, it would go first. But J and K in the middle would be somewhere right here. Like this right here, I'd probably put directly in the middle somewhere. I'd probably put this one first. Then I'd put it in this exact order. But it doesn't matter. There's no such thing as standard form at this point. But I'd put it in that order right there, definitely. Any questions? Okay, listen. Alex cheated me. Alex went ahead and changed things on me. So Alex, on your homework today, you're going to have a lot of problems that look like that one. And very, very few, if any, that look like any of the other ones we just barely practiced. Alex apparently removed the other ones and moved them to Math 3. So, there you go. Should be an easy day for you, because you only have the easy ones. I just went over there and checked, and they changed it from last year. So now I know. But, you guys will have a head jump on next year. So there you go. 9 or 10, maybe 11 problems, I think. Some are multivariate, meaning multiple variables. Where's your Chromebook? Where's it at? Is that your Black Nike backpack? You can borrow one of my Chromebooks. Do you know your Alex username and password? Just make sure you wipe it down after. Okay. Good luck. I'll be around to help as soon as I upload this thing to YouTube. Oh, I hate this job.